Welcome. In this video we are talking about subnetting, both fixed length and class boundaries. So up until this point we really haven't talked about IP classes, but an IP class predefines the subnet based off the class of the IP. So we have 5 classes, A through E, and it's based off the first octets. So if the first octet is between 0 and 126, it's known as a class A network. Class A networks have a subnet of 255.0.0.0, or commonly known as a /8. What that means is the first octet is the network portion, and the remaining 3 octets, the second, third, and fourth, deal with host bits. That means there can be 16 plus million hosts per that subnet. We have a class B, which ranges between 128 and 191. Again, the subnet for that is a /16 or a 255.255.0.0 subnet. There we have the first and second octet as network portions, and the last 2, the third and fourth, as host portions. With that, each network can have 65,534 hosts per network. Last, we have a class C network, which is 192 through 223 in the first octet. That would be the subnet of a 255.255.255.0 or /24. And here we have the network portions being the first, second, and third section, while only the fourth is tied to the hosts bits. With that, we can have 254 hosts per network. We have D and E classes. Those are special addresses that we can't really use. Also, we have 127, which is also another special type of address that is tied to loopback addresses. So these types of addresses are what we would be assigning to hosts. However, these subnets are fixed, meaning you basically divide off of the class boundary. Meaning 255, you're always going to be working on that with that /8. With a class B, you're always working with a /16. With a class C, you're always working with a /24. That makes subnetting a little easier, but that makes it a lot more wasteful. We also have a few special addresses in each class. We have what's known as private IP addresses. In class A, anything that starts with a 10 is a private IP address. With class B, anything that starts with a 172.16 through 172.31.255.255 is also a class B private IP address. Lastly, we have a class C IP address, and they start with 192.168. The third and fourth octet can be whatever they want. As long as the first 2 octets are 192.168, it's a class C private IP address. Alright, so here I have 3 networks. Class A, Class B, and Class C. So what are our groupings? Like, how do we know what a network... Alright, so let's go ahead and look at this as a binary review. We knew that we have a Class A, B, and C. Class A being a /8, a class B being a /16, and a class C being a /24. So here we have a /8. We look at the last bit. That lets us know how many usable hosts we have, and it lets us know how we are increasing our network by. So you'll notice we're increasing by our grouping size, which is 1. If we're looking at a class 16, we go to the last bit. We have 65 plus thousand usable hosts, and again we're increasing by 1. With a class C or /24, same thing. It is a, going to the last one, 256 addresses. We're grouping it or increasing it by 1. So we knew that a class C gives us 254 usable addresses. Why did this say 256? In subnetting, we have a network ID and a network broadcast. There are two specialty addresses that are not usable, so we still have to accommodate those. Lastly, we said grouping. What does that mean, grouping? We said that it's increasing by groups of 1. So let's go ahead and we're going to look at a class A. The bit is in the first octet in the last bit group, and we're increasing it by 1. So here we have our network. We have 10.0.0.0. We're going to increase the first octet by 1, meaning add 1. So the new network will be 11.0.0.0. And if we increase it again, we add 1 again, and so forth. We know that because we are adding it based off the boundary limit. The 1 is in the first octet, and we're increasing it by our grouping size. So if we look at a /16, we're in the second octet, we're increasing it by 1. Again, second octet because that's where the 1s end, and the last one is in the first position. So we look at the network we had, which is 172.16, which is the /16. We increase the second octets by 1. So each network is going to be increased by 1 in the second octet. Again, we're increasing the second octet because that's where the last 1 bit is. If we are looking at a /24, we're going to be increasing the third octet by 1. So again, we have a 192.168.0.0 /24. So we are increasing the third octet by 1. And again, they build off each other. So we're not always going to the first network. We're going to the previous network we had and adding 1. That's why this will be 1, 2, the next network will be 192.168.3.0, and so forth. That is what it means by subnetting on the class boundaries. The issue is each network in class A gives us 16 million networks. Each network in class B gives us 65,000 plus networks. In class C, we get 254 network or addresses per network. What happens if we want something in the middle? What happens if we have varying needs? That is where this is not flexible. In the next lecture, we will be reviewing how to do variable length subnets so that we can have it more flexible. If you have any questions or concerns with this material, please let me know. Thank you.